Hello, Blazers. Welcome to episode 164 of UAB Green and Told, originally released on Monday, December 1st, 2025. Through this podcast, we share the journeys and experiences of the UAB community. Want to explore past episodes? Visit alumni.uab.edu/greenandtold or find us on Spotify and the Apple Podcast app. While you're there, leave a review to help others discover us. I'm Greg Berry, a UAB alum and Director of Communications in the Office of Alumni Affairs. Before engineering ever entered the picture, today's guest was chasing a different kind of rhythm. Dustin Nolen once dreamed of making it big in Nashville, where music was more than a passion. It was a calling. For a while, it felt like the right fit. But the spotlight doesn't always shine forever. And as Dustin reveals, the music industry can be as unpredictable as it is exhilarating.
And then everything kind of fell apart with that direction. Band kind of broke apart, and at that point I'm like, okay, well, I've had my fun. It's time to get down to business.
Engineering wasn't just a new major, it was a mountain to climb. As we'll learn, Dustin had to start at the very bottom, with someone willing to guide him step by step.
She kind of took me under her wing and taught me everything back to algebra in a summer term up through Cal 2. So I was literally sitting at a desk outside her office for about 8 hours a day, 5 days a week.
Eventually, he found his groove in a subject that felt more like storytelling than science. Failure mechanics and fracture mechanics gave him a lens to see and tell the story behind every broken piece.
I was interested in that because it was like watching TV. It was, you're getting a story and then you're telling the story for the piece. And then from that, you can tell the entire story about what happened.
Dustin didn't take the straight path to engineering. He took the scenic route with detours through music and self-discovery. Growing up in Walker County and graduating from Curry High School, he once considered pre-med, but math wasn't his strong suit. Eventually, he'd pack up and head to Nashville to chase a different dream. For a while, music was the answer. But just as the rhythm started to fade, a new direction began to take shape.
Played music for a while, just trying to find myself, figure out what I wanted to do. So I moved to Nashville, played some music for a year or so. Then about the time I was going to move back, my sister had been a physics major at UAB for a year or two. And she realized, well, I think I'm going to change into mechanical engineering because there's a lot of job opportunities in that. She had changed over to mechanical and had mentioned it. And I was like, well, it's probably not a bad idea. It's close to home. I can commute, got a good program in engineering there, and so what I did is I decided to try to stick with the biology and go into biomedical engineering. And so I stuck with that for a while, but I still really didn't know what I wanted to do. I didn't really know what biomedical engineering was. To me, I thought it would be working with implants and such, which it does include that, but it turned out to be a lot of computer coding, which I do a lot of now, but wasn't very into at the time. Because of the classes, I became to be more into it and enjoy it now. So it did build my fundamentals, but it wasn't until I took a biomaterials class that I realized, well, I really enjoy the materials and the chemistry aspect. And that kind of changed everything. I had gotten in with a couple of the professors at Materials Engineering School, and they had turned me over. We came up with a plan, and it kind of just went from there.
Did you jam with anybody people would know up in Nashville when you were chasing that dream?
You see a lot of people up there, and so you would run into people, but I really didn't play with anyone notably that people would know, but I had a lot of fun in the process. You get to meet a lot of people. A lot of people practiced in storage buildings up there. And I remember we were practicing in a drummer storage building that he was on tour with some big country artist. I can't remember who it was now, but this is 25 years ago. So they're probably old and retired by now.
When did the realization set in that, you know what, maybe this musician career isn't going to pan out? What happened? What changed?
Well, we had been talking with recording agencies and ended up signing a deal with a major recording agency doing rock music, the stuff that was in back in the early 2000s. And then everything kind of fell apart with that direction. Band kind of broke apart. And at that point, I'm like, okay, well, I've had my fun. It's time to get down to business. So, come back home, start working a couple of jobs here, doing some apprenticeship carpentry, building things, working. One time I was working on a company doing roofing, doing some tree work with a company. Then about a year later, that was when I decided, yes, I'm going to school. Can't do this kind of work forever. I'd always been really mechanically inclined. My dad always took me out and made me learn how to do things. We tore engines apart when I was 12 and rebuilt engines. We would pull apart anything. As a kid, I would tear things apart. Most of the time, I would get it back together, but not all the time. But I knew I enjoyed building things and seeing how things work, but I just didn't at the time know what career paths actually did that. And so whenever I moved back and started working and building things, I realized, I understand basic concepts and have, what I feel to be normal common sense. So why not look for a career that would let me design or to test, which at the time I didn't realize the level of testing that materials actually undergo to be put into service. But turns out now I do a lot of testing and mostly forensic work because I enjoy looking at, things are going to fail, but why do they fail? And so that kind of back-ended me around to being into more of a design engineer in the last 5 or 7 years.
What instrument did you play?
I play the bass guitar.
When you made that transition from even carpentry, being a musician, back to academia, was that an easy transition after you'd been out for a little while?
I didn't notice it being that difficult. The most difficult aspect of it was getting the higher level maths under my belt, which luckily I talked to the UAB counselors at the time, and at the junior college I had taken the anatomy course, so they actually recommended I go take my physiology back at the junior college during a summer term. That way it would keep me on track and wouldn't put me behind, which was very, very lucky that they did that. And it helped me out a lot because it saved me another semester. But at the time, I took Cal 2 and was fortunate enough to get a new professor that I think she had only been out a year or two. She kind of took me under her wing and taught me everything back to algebra in a summer term up through Cal 2. So I was literally sitting at a desk outside her office for about 8 hours a day, 5 days a week. And she would show me how to do things, and then she would leave me and I would study. And so turns out I can do math and enjoy it once you get a good full lecture and understanding on it.
What was UAB like when you were on campus taking courses in engineering?
Much smaller than it is now. I was just walking through campus to go to the new engineering building opening the other day, and I honestly got lost because the landmark building was always kind of the art building because it fell in between the library, fell in between Hill, fell in between Campbell and the BEC, which is now, I don't even know what they call it now. It's changed names a couple times, but it's not there anymore. And so I was looking around, I'm like, am I standing behind the Alice Stevens Center or where am I exactly? And so it's grown quite a bit. While I was there, they had built the rec center, which was really nice to have on campus. But I remember taking differential equations in the Matthews Hall, which is no longer there. So the campus has grown quite a bit, but most of my time I stayed around the engineering school and the Hohen building.
At some point during this journey, you got introduced to Raymond Thompson, who you would end up interning with and then working alongside and then co-owning a company. At what point did those paths cross?
Well, that's an interesting story, and really one of my favorite stories about UAB, which is when I came into the materials department, there were maybe 7 to 9 of us in the materials department. It was very small, which I had heard from other students that I knew that were in other schools, larger schools, that things are so big that you get lost. Professors don't have time to know you because they may have 50 to 75 students. There were 7 to 9 of us. Every professor knew every one of us. And one of the things that they really pushed was they liked for their students to have apprenticeships or work as technicians for the professors that are there. So it gave me the opportunity to be hands-on working for a professor and get to a lot of work. So I got to do hands-on aluminum casting. I remember sitting and he had a project working on oil rig drilling bits. I didn't even know what a tungsten carbide centered drill bit was at the time. But I'm sitting here beside a saw, cutting through them for hours and getting to learn, well, how to use a saw, and get to actually see the material and process it. So I got a lot of hands-on that. What I've noticed is several interns that we have. I'm really big into having interns, but a lot of them maybe haven't even turned a wrench. And so they just haven't had I guess I was older coming into school. So I had done a lot of these things, and I always would tend to overlook people that didn't have it. I just thought everyone did that. Turns out not everyone has. So because I worked as a technician, the professor that I was working for, it was getting close to his time where he was deciding to maybe retire or cut back. So he was going to move back to where he had gone to school and kind of finish up his career. And he was friends with Dr. Thompson, who at the time was needing someone to operate some research equipment that he was running some grants for. And so I kind of just got introduced, had an interview, and started about a week later. And 18 years later, I'm still here.
That's just amazing. And at the time when you were interning, and even when you first started full time, you were at Innovation Depot, weren't you?
Yes, we were. We actually started, my first time was at the OADI building.
Okay. Which was the
So
precursor to Innovation
yes,
Depot.
yes. And so I spent about, I think it was about 4 months there. And then we moved into the Innovation Depot. And what I learned from my internship was school can only teach you so much. It was really in my internship where I started learning how to actually be an engineer. I'd gotten all of the textbook academic knowledge, and at the time I was interning, so I was still getting that. But applications don't always align with textbook learning, and applications learning is really what moves the world. And it's how things operate, and not everything can be compartmentalized into a book chapter.
When it comes to Vista Engineering and Veer, you mentioned forensics and kind of digging into the background of things and why things may fail. What does Vista Engineering and Veer do that you've been doing for the last 17, 18 years, almost 20?
Starting with Veer, we did a lot of accident reconstruction where we would see vehicular accidents, and whenever that happens, the insurance companies or attorneys, they want to know, well, what is the story here? What occurred? What led to the accident? So we would do a lot of what we call wheels and tires work, where you go out and you look for evidence from, say, where tire marks were left, or where there's upset dirt, or you look at damage to vehicles. And then that may get as complicated as calculating energies and crashing vehicles together, or it may be as simple as, well, this is the tire marks, and because they are at this angle and they look like this, then that is basically the speed that they must have been traveling. So it was a lot but on the Vista side, forensic work is related to things that have failed and maybe someone has been injured, or things that are just and cost the company money, and they need to improve their technique or their processing. So we work on both sides of litigation. We work with insurance for losses, but we also work with companies local here in town, as far as international companies, in helping them improve their processing and have less failure rates, which helps their bottom line of revenue.
You came in as an intern, you became a project manager, then president, and then co-owner. Could you have projected that career trajectory when you started as an intern so many years ago?
Oh, absolutely not. When I started here, I was getting to work on really odd equipment. As I think I had proved that I could work on this equipment, then I got more opportunities to do additional work. I had no idea what we were doing at the time, but I learned how to do it. I learned how to apply it. I was interested in studying how it worked, so a lot of that was getting physics textbooks, because we were doing microwave plasma diamond deposition, which is, I had no idea existed, and so there was a lot of learning there for me to do, but did that for about 15 years and learned quite a bit. About in 2009, that was when I really got interested into the failure mechanics and fracture mechanics, which is where you look at fractured surfaces and you determine where did the fracture occur, where did it originate, how did it happen, and then from that you can back out what kind of stresses were on the part. And then from the stresses on the part, you can tell, well, was it properly loaded, or was it improperly loaded, or was it under designed? And so I was interested in that because it was like watching TV. It was, you're getting a story, and then you're telling the story for the piece, and then from that you can tell the entire story about what happened. And telling that story was really what was interesting to me. And so I've been doing that more and more for the last 12 years. That's primarily what I do now. And a lot of that came with getting my professional engineering license, which I did about 10 years ago now.
In the 20 years you've been with Vista, how has the company changed? How has it grown?
We are a small business, and we're a very family operating type business. We operate right now with 3 full-time engineers, but as president, I'm always looking for what are the opportunities to grow. How do we add more? But then you have to do that with, in a small business, you have to do that under the limit of your cash flow. You never can over increase your employment people until you don't have the cash flow to pay for that. So we tend to grow real slow. But we're still small, but getting to do a lot of different things like the NASA project, which allows us to keep things fresh and be able to be innovative.
And I was just going to touch on that because you're a small company, but you're doing some pretty cool things that basically span the scope of, the greater world and beyond. Talk a little bit about that Phase 2 STTR contract that y'all received from NASA and what you're going to be doing with that.
We're fortunate to have good relationship with UAB through the MPAD or the Advanced Development Materials Development Group, and being a small business actually makes us a little bit more fluid to be able to go after projects like this. Larger companies don't have time to do this because they're too busy doing what they do best. But a small company, because we're a little more agile and don't have to make sure everyone is doing what the big companies are doing to make boards happy, then we're able to work on these projects. And so what we're doing there is we're helping develop a technique for taking thermoplastic composites that are reinforced with carbon fiber, and these are of higher engineered polymers like PEEK and PEI and PPS, and we're coming up with a way to join those so that when parts are designed or used and going to be trashed in space, then they would be able to repurpose those and reuse those to make other items. And ultimately what could be done is that parts are designed so that not only are they designed for their primary role, but maybe they also have features built into them so that they can be disassembled and built to a second device, because you're limited on the materials that you would have access to in an environment like that. And this gives the ability to multifunction devices and create multiple things without having to destroy and trash parts and start fresh. We're actually recycling because there's a limited supply.
Do parts and materials react differently between how they are on Earth and how they are in space?
Well, there are differences, absolutely. The temperatures are going to be different, so the processing will be different, and there's no gravity. But the good thing about our process is that we're applying an external force, so gravity likely will not affect our process as much, or the lack of gravity, just because ours is a pressure-based, and we would have a device that's going to apply the pressure to simulate the force to do the welding. But absolutely, there's been studies that have shown that gravity definitely affects certain processes. A lot of those that I've read about recently would be the 3D printing aspect, because your filament that you're extruding doesn't necessarily want to go down like it does on Earth. So I do see there being issues with certain materials, but I'm not thinking that we're going to see with this exact process. an issue.
Is it a steep learning curve figuring out what works and what doesn't work when it comes
Oh,
to?
absolutely. It's research. I kind of came into this company on research with the diamond work, and it was a difficult thing to swallow that you're not right every time. Matter of fact, you're wrong most of the time, and every once in a while you'll get a nugget that's like, okay, yeah, that worked. Especially in the diamond stuff. But uh, it is a steep learning curve. It requires a lot of work, but if it's well planned, you can optimize and do the process more efficiently. And so we try to tailor our projects to where we're doing what is required to achieve a goal, but we're not wasting time. Because if we go down too many different pathways, then we're running less efficient. And we try to minimize how long it takes to actually, and that learning curve to actually get to the goal.
You talked a little bit about the diamonds, or at least you alluded to the work on diamonds. What are you doing with diamonds? Because it's kind of cool what Vista has been doing over the years.
Well, that was based off of some work that Dr. Thompson brought out of UAB through the physics department, and Dr. Yogesh Vora was running heavy in that realm at the time, and I think he still continues that till today. He's done a lot of work in that area. But Dr. Thompson brought out and was going to commercialize the use of diamonds in certain applications. We've had a couple of NSF grants and a couple of NIH grants to develop diamond coatings on certain devices. One of those would be on lathe cutting tools, or tools that they were cutting automotive parts with on lathes. And the reason they want that is because they're wanting to go to these aluminum materials, but the aluminum does not handle wear in an engine like they would want. So what they do is they put silicon in there, which gives it a hard phase inside the material, but that gives you a difficulty in cutting, because now you get this really hard phase that doesn't want to cut. And so what they're doing is they're cutting with carbide tools, and they're having to use lubricants. And so that project was studying the use of taking those carbide tools, preparing the surface, and putting a diamond coating. And we're talking a thin diamond coating. It was 25 microns thick. So very thin coating, but it's enough of a coating so that you could cut through these parts and machine them without having to use the lubricant because of environmental hazards and the drive to want to try to get away from using these lubricants in machining. So we started with that, and then that moved over to doing some diamond coated drill bits for composites and aluminum manufacturing. But our last project that we ran with was working with UAB to do a temporal mandibular joint implant. And we worked with the dental school on this one. And the process was to coat the titanium implants with diamond and put those into animal studies using pigs. And so we did that study and showed diamond coatings could be applied to these implants. We designed the implant for the animal. They were installed into the animals, and then we studied the behavior. And the idea was on all of these was to increase a hardware surface so that we could improve the wear life of the components and reduce the amount of loss in tool changes or tooling, or increase the lifespan of the implant.
Do you think the guy that was jamming up in Nashville would ever be working with NASA, diamonds, things like that?
I did not know that I would be doing this. No, I was looking for my next gig. And it definitely wasn't this at the time.
That's Dustin Nolen, a 2008 graduate of UAB's School of Engineering, where he earned an undergraduate degree in materials engineering. His journey from music to mechanics led him to his current role as president of Vista Engineering. And through every twist and turn, he's shown what it means to forge your own path, and he has a great idea of what it means to be a blazer.
I have a lot of pride in UAB. UAB has grown so much, and I try to keep my connections with all of my professors at UAB because that's home to me. And so to me, it means a lot to be a blazer. I have a lot of friends who also graduated there. We stay in touch. I really respect the university, and I appreciate everything that they had offered me and provided me with. and through that, always visit, always stay close to them.
Thanks for tuning in to UAB Green and Told. You can catch up on all of our episodes at alumni.uab.edu/greenandtold on Spotify or the Apple Podcast app. Got an idea for a guest? We'd love to hear it. Email us at greenandtold@uab.edu and stay connected by following us on Facebook and Instagram. Thanks for listening, and as always, go Blazers.